We're all time travelers, but at a much slower rate. The concept of time travel is one that has been debated for years. Many people believe that the idea is impossible, while others claim there is proof that it exists. The truth about our reality and what it means to us is a topic that has been up for debate for a long time. Some people believe in the possibility of time travel while others think it's just a theory. There are many who claim that there is proof that time travel exists or has existed throughout history, but no one has ever been able to provide any real evidence to support their claims. Let's take a look at 11 scientific breakthroughs that bring us closer to proving that time travel may indeed be more possible than we think. 11. Albert Einstein, quantum entanglement is the proof. Einstein was not the first scientist to take an interest in whether time travel is possible. He was, however, one of the first to spend significant time thinking about it. In 1935, he wrote that quantum entanglement confirms that time travel must be possible because entangled particles can be separated by space and distance, but still react to changes in each other instantaneously. This would only be possible if both particles were not just carrying a copy of the same information, but were actually acting as one system. This phenomenon can be explained with the help of the theory of relativity. The theory says that two particles may interact even if they are separated by long distances, and this interaction does not depend on the distance between them. 10. Wormholes. Recently, the world was taken by surprise when scientists found a wormhole in space. Wormholes are one of the possibilities of time travel, and this discovery proved that it is possible. The discovery was made by a team of researchers from the University of Rochester in New York. The wormhole is not like any other we have seen before. It does not lead to distant galaxies, but instead to another point in space-time. This wormhole could help explain some other mysteries, such as dark matter and dark energy. This breakthrough could also provide answers to some deep space mysteries, such as black holes and gravitational waves. Some scientists theorize that wormholes are shortcuts or bridges through space-time, connecting two points in the universe, which are not connected by paths in the standard four-dimensional sense. These wormholes are also called Einstein-Rosen bridges. 9. The tachyonic antitelephone. A tachyonic antitelephone is a device that can send information back in time. It was only discovered in the last few decades and has been one of the most researched topics in theoretical physics. This device would be able to transmit data through time and space via a closed time-like curve. The first tachyonic antitelephone was theorized by physicist Gerard T. Hooft, who introduced the concept of using 10 dimensions that are compactified on top of each other to explain how particles can communicate faster than the speed of light. However, it wasn't until John Cramer published his work called Transmission of Energy from Future to Past that people began discussing this theory widely around the world. 8. TRAPPIST-1, an exoplanet. Have you ever wondered if time travel was possible and how it would work? Well, the NASA team has found an exoplanet called TRAPPIST, one which is right outside our own solar system, and this planet could be the first step up to solving the mystery. If time travel is possible, then we will be able to visit the TRAPPIST-1 planet when it is in its habitable zone. Even if we can't time travel, research on exoplanets has led scientists to believe that there may be an abundance of worlds like this one in our galaxy. Many people think that with enough technology and resources, we'll be able to build a machine that can send us back in time. But even if we can't do it yet, scientists have found ways to study exoplanets and their atmospheres. 7. Faster than light speed travel. Time travel is a concept in which a person or object can travel in time to the past. It has been debated for centuries, and there are many theories on how it could work. The most popular one is based on the idea of faster-than-light traveling, also known as warp drive, which would then propel the ship faster than light and ultimately into the past. In their study, the scientists from the University of Queensland and Monash University created a theoretical model for how humans might be able to achieve time travel with currently known laws of physics. The laws of physics, as we know them, restrict the possibility of time travel. However, there may be a way to achieve it with current technology. 6. Superluminal propagation of waves. The propagation of waves can refer to the movement or transfer of energy in one form or another. This may be through sound, water, radio waves, or other forms. It is a process that describes how electromagnetic pulses travel through air at the speed of light. Since the speed of light is finite, it cannot exceed this limit no matter how intense the electrical field may become. This idea has been challenged by several physicists who have come up with many different theories on how to surpass the velocity of light and thus time travel. The speed of light can be thought of as the maximum speed that any information-bearing signal can propagate in a vacuum. There is an upper limit to how fast any message or information can travel. This upper limit is also known as the velocity of light. If we can break this speed and propagate waves beyond the speed of light, time travel may in fact become possible. 5. Quantum entanglement. It's the strangest thing in the world, and it has been a mystery for many years. But science has finally found an answer. When people talk about time travel, they usually mean traveling into the future or into the past. However, what we call time travel may just be a reflection of quantum entanglement. What is quantum entanglement? It is when two particles, such as photons, are created at the same instant and then move apart from each other. They will always have a connection no matter how far away they are from one another, even if one of them was sent to Neptune and back. This connection between photons is so strong that no matter how much energy you put between them, you can never break it. This means that there is always a connection between these particles, and any time it would take to travel between them in a normal sense would be eliminated. 4. Non-locality. Non-locality is a term that describes the ability for two particles to change properties, such as spin and location, when they are separated. This has led some scientists to believe that it's possible for the past to affect the future because of non-locality. This could be interpreted as evidence that time travel is possible. Knowing that reality is not constrained by time and space, we can see how time travel could be possible. Theoretical physicist Michio Kaku said the following about the existence of time travel. Theoretically, it's possible. It violates our sense of cause and effect. But if you change the laws of physics, then it becomes a possibility. 3. Bell violation experiment. In the Bell violation experiment, scientists sent a beam of particles called photons through a barrier and then observed how they interfered with each other. The photons were not interacting with anything in between the two barriers, but their behavior changed when they passed through. This suggested that some kind of influence traveled back in time and made changes. The Bell violation experiment was an experiment done by John Stuart Bell in 1964. He directed a beam of light at two partially directed mirrors and found that the light would always scatter in one direction or another, even though it had not interacted with anything along its path. Is this the first step to understanding time travel? Could all of these scientific breakthroughs prove that time travel could in fact be possible? 2. Hawking radiation in the holographic universe. Time travel. When we talk about time travel, we usually refer to the past or the future. But in a holographic universe, there is no such thing as time because all points in space and all moments of time are equally real. That means that it's possible for us to be able to travel not only forward and backward in time, but also sideways and every other direction beyond our imagination. But don't get too excited about it because we can't actually do this right now. If we live in a holographic universe and our brains are just receivers of information, then we might be able to use Hawking radiation to travel through time. Physicist Kip Thorne and his colleagues have proposed a theory of using this type of radiation to theoretically leap into the future by millions or billions of years. The process would involve creating a copy of oneself in the future and then retrieving that copy back to the present. 1. Cosmic string theory. Cosmic string theory or brain theory proves time travel possible because they both suggest that the universe might have more dimensions than we can see. If this were true, then there would be multiple dimensions of time, as well as space. One concern with cosmic string theory, however, is that it does not account for quantum entanglement. If you send an object back in time and then destroy or change it, you will also change its present self because the future self was entangled with its past self. In cosmic string theory, a spider web of strings is the all-encompassing force that created our universe. In this theory, it is possible to travel back in time by going from one string to another. How close does this bring us to proving if time travel can really be achieved? Only time will tell. Stay tuned for more next time. If you like this video, hit the thumbs up icon. Don't forget to subscribe and hit the bell icon to get notifications for new videos.